Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on February 17, 2026, just about 4 days ago. It introduces a novel technique called dual steering, which uses information geometry to robustly manipulate a target concept in a model, while minimizing changes to off-target concepts, offering a major upgrade over traditional Euclidean methods. The paper is titled, The Information Geometry of Softmax, Probing and Steering. And as we'll see later, the results show a striking improvement in stability when steering large language models and vision systems. So Figure 1 illustrates the core problem. Standard steering methods often leak probability into unrelated concepts. In the top row, which depicts Euclidean steering, notice the large green regions expanding. For the large language model on the left, simply steering a verb to third person accidentally boosts the word to, while for clip in the center, steering cat to dog wrongly amplifies a hybrid cat plus dog image. Contrast that with the bottom row, which demonstrates dual steering. Here, the transitions are clean. Probability shifts directly from maintain to maintains or cat to dog without distorting the rest of the distribution. Well, Figure 2 explains the underlying geometry driving these behaviors by comparing primal interpolation on the left with dual interpolation on the right. In the top row, notice how the primal plot for the language model minimizes the specific answers Paris and Berlin in the middle, boosting shared words like the instead. It acts like an intersection, or an AND operator. In contrast, the dual interpolation on the right creates a smooth linear mixture. The bottom row shows this even more clearly. Primal interpolation forces a black and white dog to appear in the middle, while the dual approach simply transitions the probability mass. Alright, moving on. Figure 3 illustrates the theoretical goal of this robust steering. It visualizes the probability space as a set of blocks, where the top colored rows represent counterfactual pairs, like father and mother, and the bottom gray row represents neutral terms like friend. Ideally, when we steer from male to female, we want to shift the internal balance of the pairs, moving the vertical purple bar to the left, so that father becomes mother. However, notice that the total height of each block stays exactly the same. This means the overall probability of being a parent or a friend doesn't change, preventing the kind of semantic leakage we saw earlier. Okay, Figure 3 set the theoretical stage. Now Figure 4 presents the experimental results across 3 tasks, ranging from translating English to French on the left to changing image colors and objects on the right. The top row tracks the total probability assigned to relevant concepts. Notice how the blue Euclidean lines dip significantly, meaning the model loses track of the context, while the orange dual steering lines remain stable. The difference is even clearer in the middle and bottom rows, which measure disruption to unrelated concepts. Here, lower is better. The blue lines spike immediately, showing that standard steering damages the model's general knowledge, whereas the orange lines stay flat, proving dual steering is far more surgical. So, having seen the performance gains, Figure 5 reveals the geometric reason why. These 12 plots track the cosine similarity between the steering update and the true concept direction, effectively measuring if the model is moving where we want it to. Across all tasks, from language models on the left to image datasets on the right, the red dual steering curves consistently stay well above the blue Euclidean baselines. This confirms that the new method successfully navigates the curve geometry, keeping the update aligned with the target concept, whereas Euclidean methods get deflected. Wrapping up, the key lesson here is that assuming a flat Euclidean geometry for AI models fundamentally limits our ability to control them. By adopting information geometry, dual steering proves we can manipulate specific concepts surgically without damaging the model's broader knowledge. This suggests a promising path toward more reliable and interpretable AI systems. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.